Hello, everybody. I'm Subhajeet Mukherjee, as she already said. I'm currently a CS student, and I've always been obsessed with operating systems. It just like I started using computers when I was 4. My dad bought me this super old 120 megabytes computer. It was running Windows 95, and since 7 years old, I loved it. The whole OS concepts. Thank you so much for hosting me today over here. And if anyone of you are using laptops, then you could access the slides at bit.ly. I tried to shorten the URL so that you can access it. So let's talk about the agendas. So talking about this kind of things is very much a boring topic sometimes. Like people get bored talking about operating systems and things, and things can get monotonous at the same time. So this would be fairly technical at the same time, and there would be Q&A sessions, 3 to 5 minutes, depending on what kind of section it is. So basically, I divided the section, the whole talk in 3 sections. The first one is I'm going to talk about structural and architectural differences between major operating system families. The second one is going to be security implementation, and there's nothing that much things to talk about it because I think it's a huge chapter of its own. So it's kind of hard for me to like put that thing in one single situation. In fact, Liana and I had extensive discussions on this, whether what to include and what not. So this is kind of a tough thing, and putting everything, compressing everything within like 1 hour is kind of a hard thing to do. And the last one, I'm going to talk about the architectural and security implementations that I've done in the OS that I've been working on. And just to have that flow, we can have Q&A sessions after each sections. So the first one is structural differences between major OS families. Okay, so the thing that I realized that putting the first thing that I think should include is the licenses, and licenses play a huge part in terms of code bases and developers at the same time. In fact, commercial companies, even if you're individual, licenses matter a lot. So it's kind of like a crucial aspect of building anything, not just operating systems and other things. So I categorized it with 2 main and pretty much famous licenses. Is basically the permissive licenses or the less restrictive licenses, and the other one is the protective licenses. So and I was thinking there are a huge amount of other licenses at the same time. They're famous as well, but for this context, talking about this 2 category of licenses would do the job. In fact, I also created another. On the next slide, I'm going to discuss some of the famous softwares that use similar licenses at the same time. So at first, we have the BSD as a permissive license, and I personally prefer BSD. It stands for Berkeley Software Distribution, and there's MIT at the same time. They're pretty similar. Apache 2.0 is from the Apache Software Foundation. Protected licenses include GPL, Richard Stallman, brainchild. And also the Free Software Foundation supports GPL v2, version 3, version 10, or other things. So let's move on to the license comparison, because this is super informative actually, and no other source better than Wikipedia in terms of this kind of things. So have the V copyleft licenses, which are somewhere in the middle. It's less restrictive, but not as freedom as permissive licenses. So public domains, MIT, BSD, as I said, all of those things are based on the the permissive category, and on the other hand, the strong copyleft licenses include GPL2. In fact, the Linus Torvalds, the creator of Linux, he uses GPL version 2 on his Linux kernel. There are operating systems that are based on BSD license, and depending on what kind of project you're working on and what your motivation is certainly is a crucial thing to think about. Apache, OpenOffice, Android, those are basically permissive licenses. On the other hand, you have the Mozilla public licenses that are that Firefox has, and Thunderbird and everything. So licenses play a crucial role. So I was thinking, just putting that thing up as an informative. So major families. So I'm not gonna talk about lame stuff like whether Windows is better than Unix or something, because that sucks. But the Unix family is the one that is super famous, and we already know about this. This Mac is running on the Unix, but I wanted to mention that there's people always mistake Unix as just an only operating system, but there's Unix at the same time, which is a trademark, is by the open group. So that's why I put a not equals, because I thought that that's crucial for this. But the Unix started at the AT&T Bell Labs, and then they made it open to the institution and research universities so that they can tweak it or do research on top of it. So the famous Unix variant or derivative is BSD. Again, Berkeley Software Distribution. People confuse that BSD is only a license, but no, this is both. BSD is also an operating system at the same time. There's also XNU, and in fact, this is very tricky because XNU is by Apple, and XNU uses a hybrid kernel. The structure of the kernel is hybrid. So I'm going to talk about the hybrid kernel and all those kind of things a bit later. But for now, it's just XNU is a kernel that is being used on iPhones, literally iOS and macOS. It has proprietary stuff in that. On the other hand, you see Darwin, which is Apple's public and open source operating system. It doesn't have the proprietary components that Mac OS have, but it's literally the base of the OS that makes it Mac OS and iOS. So Darwin has components from FreeBSD. There's also components of 4.3 BSD, and I think the other one is Mark. So these are the three components that Darwin uses, and XNU has already inherited some of the components from that, and they keep updating, especially the FreeBSD stuff. On the other hand, so that was the whole Unix family, and in fact I categorized Unix-like family because I think it's super controversial, and it's always better to talk differentiate between the two, because even though they share the same POSIX compatibility, they still have some license differences. So the Windows NT family is very interesting. So since 1993. All of the Windows that got released, all of the Windows that was released by Microsoft is based on Windows NT kernel, and they don't name individual stuff like this kernel is the name of this, but it's just generic Windows NT family. Windows NT family has hybrid option at the same time, the new ones, since Windows XP, and I'm going to talk about those a bit later when I'm going to discuss about the structural elements of the kernels. Unix-like family, and people mistake, and even some of the people that I met, they mistake Linux as an operating system. And I just thought to be technically correct because Linux is a kernel. It runs as a distribution underneath something. So very much crucial to know about that. And Android is basically Linux. We all know that. And so that was kind of the Unix-like family and Unix family differences and Windows NT. And there are other families at the same time, but like HiQ, that's a bit different category on the microkernel side. But yeah, these are the famous ones. So I didn't talk about I didn't differentiate between the Unix and Linux because I thought is POSIX compatible. Structurally they're very less different. But if we putting Unix and Windows NT family has things to talk about in terms of some major differences. So the windowing system in Unix families in general runs on the user space, and this is contradictory to the Windows NT family. And by Windows I mean the releases that was done after 1993. So the windowing system in the Unix family is separate from the kernel space. Kernel space is, there are two spaces in general, user space and kernel space. So the windowing system runs on the user space in general in Unix systems. That's the same thing with Linux at the same time. But in Windows NT, I think, yeah, but in Windows NT, what I realized that they had this kind of thing before Windows NT. So Windows 3.1 or the previous ones, they had windowing system running on the user space, but they were working on Windows, the DirectX and all those kind of things. So they thought it would be better for them to if they put that on the privileged mode. And by privileged, I mean the root mode, where the kernel space, so that they can increase the performance. And so the graphics performance were better in terms of that. So the windowing system is something to talk about in terms of these two categories. On the other hand, the file system varies on what kind of Unix distribution you're using. Apple uses AFS, that's the proprietary ones. There's OpenZFS, ZFS was made by the Sun Microsystems, and then they got bought by Oracle. So, but they had made this OpenZFS, which is based on the CDDL license, and it's actually a fork of Mozilla public license. So it's somewhere in the is in the middle of copyleft and permissive category. And the Unix file system is already there, it's being developed at the same time. But majority of the BSD or Unix distributions currently use OpenZFS. And in fact, OpenZFS has already introduced some of the crucial aspects of file systems and generic stuffs. But Windows NT or Windows family in general uses Microsoft proprietary NTFS, or the new technology file system. It's proprietary, and they also have the other proprietary system, but that's their primary ones that they use on the Windows family. So, I mean, I was thinking of putting the whole kernel architectures separately, but this was the best in terms of comparing side by side. So you have this applications that run on the user space in general, and this is like the standard that is supposed to do. On the other hand, you have three kinds of kernel, and in general, there's two kinds of, but there's another category that got invented in the early 2000s. So it was the hybrid kernel, and it's controversial. I'm coming back to this, but the monolithic kernel, is fully kernel space. So majority of the components that the kernel has runs on the kernel space. In fact, Linux, FreeBSD, all those kind of operating systems in general runs the monolithic kernel. So the virtual file system, inter-process communication, file systems, and the scheduler, virtual memory, all of them are running on the kernel space. And it gives you the God mode turn-ons, like that kind of privilege. On the other hand, microkernel was made, and in fact, there's a good example of microkernel, which is called RTOS. Pebble, the watch that they made, is based on RT. It's real time. It's supposed to be a bit faster feedback, but majority of the thing runs on the user space, except the virtual memory scheduling. But the normal application inter-process communications runs on the user space. So this thing was there, and RTOS is one of the examples of microkernel. There are other ones. In fact, I think Haiku is an example of microkernel. So both has their own good things at the same time. For instance, monolithic is more of a bigger system management, whereas microkernels are for small devices, especially for embedded systems and so they had this, but they thought like putting the best of both worlds. In fact, the idea was to put, you have the microkernel and monolithic, and so we're going to make a monolithic kernel that takes some inspiration from the microkernel, so that the user has less privilege and less exploitation in terms of accessing the file system and everything. So the hybrid kernel came out, and the first, the Windows XP had the first hybrid kernel in their category, in the Windows NT family. Mac OS already had that, so similar hybrid kernel concept came on. In fact, this is kind of confusing because Linus Torvalds, the creator of Linux, he thinks the whole idea of, I read this somewhere, that the whole concept of hybrid kernel is just a marketing strategy, because it just sounds very cool and sci-fi, whatever that is. So basically, there's not that much difference, and I kind of agree with them, because only the file server and Unix server, and by Unix server I mean the Windows system, the X server, is running on the user space. So it's literally the same thing in some ways if you look at that, but except the device drivers, because you need more access to the device in the kernel space, and that's why you need to utilize the kernel space for the device drivers. So that was the main concept. Any questions? So the whole idea of XNU was, okay, so the question is, how did Apple choose the XNU? Am I right? Like, that's, yeah. So I haven't worked at Apple, so I can't really tell it, but as far as my understanding goes, Carnegie Mellon was working on the Mach kernel. On the other hand, you see 4.3 BSD that got discontinued, but then FreeBSD came. So they were, and I think that was the time when they had the next step at the same time. So they were taking inspiration, and the reason of putting the file servers on the user space is for the security reasons, because you give less permissions. That's why even if you use super user, sudo, in terminal, you're still using in the user space. You still have less power and authority of the, whereas in kernel space you have more restrictions towards the user itself. So that was a security implementation. Any other questions? All right. So I'm going to move towards the security implementation, and in fact, there's only 3 slides, and I thought about putting more slides, but that's a completely different chapter, and it's hard for me to put everything together. So the security key points. Okay, so an operating system has 3 kinds of main security stuff. There are other portions as well, very hierarchical. But I thought putting 3 stuff, like one is the kernel level security, which deals at the very low level in terms of drivers and everything. And kernel owns majority of the drivers in the kernel space. On the other hand, we have the file system security, which I'm going to talk about a bit later. But the file system security includes securities, permissions, the user permissions, read, write, execute, that kind of permission, and which one do you give. File systems include daemon, which is also a huge part of the Unix systems. And there are other encryption technologies invented for file systems, including EFS and others. So that's another broad topic. But the user level security is the most basic thing, very vulnerable to security flaws. Includes passwords, usernames, check, and the basic ones. So now the security portion. So I was talking about the file system security, and in fact this was first conceptualized in one of the papers that were released in the Linux packs. I'm pretty sure it's 2002, around that time, when the whole concept of ASLR came, and it was a security implementation that you would do that would prevent memory corruption vulnerabilities and potential exploits that can be done by hackers and everything. So I was thinking of, and I'm not an expert in terms of file system security, so I thought of putting the most easy definition of that. And it literally arranges address spaces by randomizing positions of the areas of process, the base of the executable, the binaries and everything, and the heaps and stacks. It goes towards the pointer level precision and does the address level layout randomization. And in fact, Linux implemented a very weaker version of the ASLR, and then OpenBSD, which is also based on the ISC and BSD license combined, was the first one that was successfully and fully, I would say not successfully, but fully implementing that ASLR in the operating system. There's another thing called KSLR. It's also super level, low level, it's kernel level. And it does the same exact thing. You take the binaries, you put it in a random location so that every single time every user will have a different space to run on. That means you don't have any, you have less probability of exploiting the kernel. There's another thing called Carl, and I'm not going to talk about it right now because at the end I'm going to talk about why I implemented that on my system. But yeah, I will come back to this later. So I was talking about the file system security, and usually the security includes prevention of race conditions. And in fact, the easiest way to explain race conditions is when one or more programs try to attempt or access a certain level of files and changes things. So when, as the name suggests, race conditions, and it's gonna corrupt the data. And there are ways to prevent that. There's very long ways of preventing that, like the daemon that does that. In Linux systems or Unix systems in general. There's also the access control that I said, read, write, execution permissions given to the user So that's all. That covers another file system protocols. The data protection is super basic, having backups, recovery, and others, and various encryption concepts like the EFS and everything. So that was kind of the end of the second half. Any questions? All right. This is going to be the longest because the architectural and security implementation of the OS. So this is the basic system structure that I have on my OS. It follows a hybrid kernel concept, has the display server and graphical windowing system and the user interface, which is basically the desktop environment. And you have the applications running on the user mode and the user absolute. There's also a graphical windowing system, so it runs on X window system, a modified version of that. So there's an ML layer, which is basically a TensorFlow running on the desktop environment to understand the user activities and not making any suggestions, but taking actions that will eventually make it easier for the user. So this is the kernel structure that in my OS. So it's basically takes the NetBSD and there's a thing about it. So when FreeBSD started, NetBSD was derived from FreeBSD, and the main goal was to have more portability, more device accessibility, and supporting more devices and hardwares. So that was the goal of NetBSD. It has a BSD license at the same time, super permissive. And the good thing about permissive licenses, you take the source code, you give credit to them, and you build proprietary software on top of that. That reduces a huge amount of time for corporations and commercial things. I personally prefer the BSD license, as I said, so it is certainly helpful, but it is very subjective. People prefer GPL, and GPL is very enforcing in that sense, because every single time you use the GPL license, you have to make depending on what kind of license it is and the conditions that it has, you have to make it open source. Anything that is based on GPL or uses GPL source codes has to be open source. So there are cases where companies would use GPL code without even knowing that, and suddenly they have to create that open source, and there you go, they just lost a bunch of money on something, and then they have to come up with a new idea to implement that in a proprietary environment. So the OS tech security and portability components from OpenBSD and NetBSD. And OpenBSD literally uses their own ideas in terms of security implementation. In fact, they are the ones that introduced this Carl, which I'm going to talk about, and the portability components from NetBSD. It's very interesting. So the OS has the NetBSD components and the OpenBSD components for security. The base is FreeBSD. It's a heavily modified FreeBSD to run on certain hardwares and processors. So, and it does have a proprietary base. So it's just some code that I contributed by myself. And so this picture can be a bit confusing because I tried to put a huge amount of information on that, but that's basically the kernel structure of the OS, and all of them, in general, is monolithic. So OpenBSD is monolithic, NetBSD, FreeBSD, all of them are monolithic in general. So by definition of hybrid, it is already there. But there's a difference because I tried to implement the drivers and the inter-process communication for applications on the kernel space, which is the blue one, and the the red one is file server on the Unix server, which is the X window system. And the application runs on user space in general. So for the kernel level security, it is using Carl because it takes the security components from OpenBSD. It inherits some of the things of OpenBSD in terms of security is concerned. And so Carl stands for kernel address randomization link, and it's very similar to KSLR. The difference is address phrase layout randomization changes the location of the thing that is changing. So, but in Carl, the binaries are the location and the pointer on the stacks and heaps of the binaries that the kernel is based on changes, but the kernel doesn't change its location. And in fact, this is not a huge improvement over KSLR, but it's certainly combining both methods at the same time reduces the probability of the exploiter in a huge manner. And it does support file system UFS and ZFS, the Unix file system, and the OpenZFS. I should have included that. So by default, I use OpenZFS on that, and that's the security structure on this. Now, hardware support. So I currently run this on Intel x86-64 architecture, and it's pretty general, runs on that, but in the future I have plans to eventually shift to RISC-V, and there's good things about RISC-V. I don't have the hardware right now, so parallelly building it on an emulator. But the good thing about RISC-V is that it's open instruction set. So anything, it's literally like BSD, is permissive. There's no charges for patents and writes. So that will eventually turn down the cost of normal computers that we buy that is based on Intel architecture or ARM, and reduce the whole patent fees that we have to pay at the same time for Intel processors and something. And it's royalty free, as I said. So this will this is currently has a huge kind of open community that is working on this project, and there are companies that are building new kind of hardwares based on that. And in terms of compatibility, it is very easy to implement Intel applications because there's going to be a compatibility layer on the OS. And in fact, the thing that I'm working on right now is building this on the x64 architecture and parallelly in the RISC-V, so that it's going to be not an issue to move on to that. So, and it does support Vulkan, and there's good things about it. And in fact, there's companies that support this, including NVIDIA, that is supporting this API. So we literally use in normal Unix systems and desktop environments, they use OpenGL. It's super famous. Even Android uses that. I think Mac changed to Metal 2 or 3 years ago, but OpenGL is still heavily used. It's still being updated. But there are some issues with OpenGL in terms of as per the concurrency or multi-threading is concerned. So OpenGL is not meant for sequential. I wouldn't say sequential, but concurrency application is it's hard for the programmers to develop for OpenGL for multi-threading apps for in OpenGL because it's just hard to like implement. But in Vulkan, multi-threading is a feature, so it's very easy. Even in the multi-threading, I get confused in multi-threading a lot of times. but it's basically C++, and multi-threading is more friendly than Vulkan. OpenGL has one global state machine. So if we talk about the finite state machines, it is very sequentially done. So every process is being done sequentially, even though OpenGL is very widely used. Whereas Vulkan is more object based. So it's more decentralized in that sense. You can call a random object. For the GPU sync, until now, the GPU sync and all those kind of things in OpenGL were not usually visible. You cannot tweak it that well. It's not that low level at the same time. But in Vulkan, it's super low level, and you can literally tweak with the memory sync and the user controls over that. So I checked this game running on Vulkan, the super high, very latest game that is running on a highly graphically intensive. So in Vulkan, the same game is running on 120 frames per second, whereas on OpenGL is 49 frames per second in an X-based system. I have given a link for the CPU efficiency, but I'm not going to show it because it's probably going to take a long time for that. But it's by ARM, so definitely worth to check. It literally shows the CPU efficiency visually. Okay, so I'm going to give a demo of the OS. In fact, I thought about showing that on real time, but my VirtualBox on Kernel keeps crashing. So this is currently running the OS in Kernel, and it does have a scrollable user-friendly. This is x64 architecture, and this is the desktop environment that I'm building, and it's fully not done yet. It also utilizing the ML layer that I talked about. So, and it does have a time notification system, and again based on the X window system. But the time notification, I couldn't show it. I really wanted to show it, but it was super buggy. And TensorFlow on free BSD in general is very hard to implement because they have less support. On the other hand, you see the same kernel running on the same kernel, and I just wanted to show a feature. And by the way, this is using the Lumina desktop, which is also a BSD license. In fact, the Lumina desktop is from the True BSD or PC BSD, which is a graphical PC implementation of FreeBSD, and it's very good. So Lumina is basically uses QSS. For normal extension-based programming. And so I implemented this feature called system-wide multiple text selection tool. So by default in normal, in very famous applications like Sublime Text or others, you could select multiple portions of a paragraph by pressing Control or Command depending on what you're working on. But from now on, you could select multiple portions of the text regardless of any application. And by default, I'm running Firefox right now, and by default Firefox has this implementation where you can select multiple portions of the text, but it was not implemented system-wide. So I personally felt frustrated because I really love that feature, and so I implemented this system-wide. So yeah, so this is already there in Firefox, but from now on, you see, and this is running external because this is based on the Unix, and running on the user space. So I could select multiple texts in any application, regardless of whether it's new or not. So it's not developer dependent anymore. It's independent. So in fact, I was talking with Liana, and I think it was better to talk about some of the external and abstract features of why I'm creating this OS. And so one of the problems that I realized that there's a problem with focusing, and there's problems with distractions. I mean, when you have a huge amount of multitasking features in modern operating systems, you're also giving huge amount of freedom to the user that reduces their productivity in some ways. So this is a visual implementation of the problem. So let's think about, in fact, I think of so let's say you're working on something that is super crucial, Word document, anything that is close to you, and you don't want to get distracted. And there are questions can come out that there's do not disturb and other options, but I'm going to talk about those things later. And suddenly you get a notification from any application, and then you get distracted, and then what happens is one application leads to another one, and that is a huge problem. In fact, instead of preparing for this talk yesterday, I was watching 4 hours of YouTube videos, and that's terrible. So what happens? You go to this notification that you get from music streaming service, and they're asking you to check out the Billboard Hot 100 playlist, and you just go there, and suddenly you see a new artist and you love it. Then you go to your browser to check out the music videos of that. And it keeps going on and on until you come back to the main focus bubble. So it's a huge problem. And according to Do Not Disturb and others, there are less implementations in majority of the operating system, and also it doesn't work that well depending on what the user is working on. And there's also a thing that I wrote in terms of the reverse psychology. So the people, we always have a tendency to press something that we are not supposed to. We press, it says do not touch the red button, but we still press it. So thinking of that same thing, but reverse in terms of do not disturb is something that I thought about. So the user gets notified about something while the user is working on something crucial, and there's a high probability the user is going to click it depending on how lucrative that notification is, and there's high probability that the user is going to be distracted for a long time until he comes back to the focus bubble. That's one of the features that I'm implementing with the time notification system. So I personally thought about this, and some of the high-level reasons and very abstract reasons of the problem includes that I personally think that humans should evolve with technology instead of just being blatant consumers at some point, except the developers. There's ambiguous gestures in modern operating systems. We are seeing it's more visible in terms of gestural combinations. Sometimes it becomes harder for the user to remember all the gestures to be productive. So that always reduces consistency and usability. Very subjective, but it is still there. And in terms of the service and research, I put a link in terms of that. So a study by Stanford University states that multitasking never works. Moreover, it harms our brains. Another study by Adobe states that only 1 out of 4 people live up to their creative potential while in this kind of situation. So that was kind of the high-level reasons. And there were other small implementation reasons at the same time, which was more about the usability. So the solutions that I'm doing in this OS is the first one is the time notification system, and that's why I mentioned about the TensorFlow layer that I'm doing on the desktop environment. Depending on what the user is working on and categorizing it, whether it's a text-based application or something, and depending on where the notification is coming from, is gonna make the notification time. So either the user gets to interact with the application for a very limited amount of time, and then comes back to the focus bubble, so that it doesn't let you go into those kind of. In fact, there are applications that completely blocks third-party application completely blocks the user's ability to access certain application. But I think that's super enforced and very much subjective to the user, whether the user is going to use it or not. So it should be organic at the same time. And as I said, reduce gestures, reduce multitasking, and that doesn't mean that it doesn't have any multitasking features, but it just means that depending on what the user is working on, it's gonna give you that kind of abilities, so that you don't lose focus. I showed the scrollable user interface. That means the whole desktop concept is not there. You access applications that you want through a scrollable user interface. You certainly have a search bar, very good, but there's no recent apps or something. Because what happens with recent apps is you go to Android, you have an iPhone, it doesn't matter, regardless of any OS, you see the recent apps that you have used, for instance, WhatsApp, Facebook, whatever that is, and you keep being in a loop every single day of using the same applications instead of doing what is necessary. And again, the usability and accessibility features. I cannot talk about the whole things right now, because it's super broad. Talking about all those things and implementing all those things by myself takes a huge amount of time, and it's certainly a hard thing to talk about. So these are the references of the ones that I got. It's on the slideshow. Thank you. Thank you so much for hosting me. Any questions? Yeah. Currently, it runs on the FreeBSD packages. Yes.
And so all your applications are on modified FreeBSD programs?
Yeah. Yeah, so the things that are going to run on BSD, FreeBSD, is going to run on this for a while, because it takes time to like modify, creating your own binaries and that. But it's in the future, yes. Yeah.
Did you think about that?
I've thought about the things that he said, and the reason I said that I was taking security components for OpenBSD, because it literally reduces my effort in terms of implementing that kind of features. But it doesn't fix the problem that I'm talking about. But it's certainly a huge scope for me to implement that, and I'm certainly going to think about that. Yeah. So currently I'm doing everything by myself, basically, and so I have to look at, even I'm working on to create my own fonts at the same time, because I think that plays a crucial role in terms of the user interface. But yeah, as I said, that I was partially building on the RISC-V architecture, which is the open instruction set. That's surely in my plans, but this is not going to be a open source operating system, except the ones that I'm taking from FreeBSD, OpenBSD, and NetBSD. But yeah, in the future, going for a proprietary system is the goal. Yeah. Because I think there are good sides in both things. Like open source has its good stuff, and proprietary things has its good stuff. I think the good thing about proprietary stuff is it surely makes the things a bit more polished than open source desktop, and I'm talking about the desktop environment, not all technology, because open source has great technology. TensorFlow, I'm using that, and basically open source. I mean, it was made by Google, so there's good things about both sides here.
Okay, let's give him a round of applause.
Thank you.